Next one is the sixth one, that is the property of Laplace of derivative. Suppose we have to find the Laplace transform of derivative of any function. So there is a generalized formula, Laplace transform of nth derivative f and t, means nth derivative of ft. So it is s raised to n Laplace of ft minus s raised to n minus 1 into f0, means value of the function ft at the point t equal to 0, minus s raised to n minus 2 and f dash 0, and minus s raised to n minus 3 f double dash 0, and so on. So when we get s raised to 0, then at last we get f raised to n minus 1 at the point 0. That is called the formula of Laplace of derivative or nth derivative, and it is also called generalized formula for Laplace of derivative. I will explain this formula taking various values of n for n equal to 1. Suppose we have to find the Laplace transform of first derivative, that is Laplace of f dash t. So it becomes s raised to 1 means s into Laplace of ft as it is minus f0, right? That is the expansion of Laplace of f dash t. Now see here, the Laplace of first derivative expansion contains two terms, right? Here first derivative and its expansion contains two terms, that is n plus 1, means one more of derivative. Similarly, when n equal to 2, so Laplace of second derivative of ft is s square into Laplace of ft minus s into f0, means value of function at the point 0, and minus f dash 0. Clearly this expansion also contains the total number of terms are 3, and here power of f means derivative order is 2. So clearly here also number of terms are n plus 1, that is 2 plus 1, that is 3. Similarly, now next when n equal to 3, means we have to find the Laplace transform of third derivative of the function ft. Then it becomes s cube Laplace of ft minus s square into f0 minus s into f dash 0 and minus f double dash 0. So clearly here we have to find the Laplace of third derivative, means value of n is 3. So number of terms of this expansion contains 4, that is n plus 1, 3 plus 1 is 4. So that is the concept and formula of Laplace of derivative. And after that I will take one example based on this formula Laplace of derivative. Find the Laplace of cos root t by root t. If we have given Laplace of sin root t is root pi into e raised to minus 1 upon 4s upon 2 into s raised to 3 by 2. So now see here, let our function is ft is sin root t. We are assuming the function ft is sin root t because its derivative we get the cos root t by root t. So first we will take the ft sin root t, and the derivative of f dash t we get the derivative of sin root t is cos root t, and the derivative of root t is 1 upon twice into root t. We know that. So it becomes cos root t upon twice of root t, that is f dash t. And after that we will taking the Laplace transform both sides of this equation, then we get Laplace of f dash t is equal to Laplace of cos root t upon root t, and 1 by 2 is constant, so taking common outside L. And then we will use the formula Laplace of derivative in left hand side of this equation. So here we have to the value s raised to 1 Laplace of ft minus s raised to n minus 1 means 1 minus 1 0 into f of 0 equal to 1 upon 2 and Laplace of cos root t upon root t as it is. We have to find the value of Laplace of cos root t by root t. So remaining terms we will solve here, and s into Laplace of ft. Our ft is sin root t and its Laplace is given root pi upon 2 into e raised to minus 1 upon 4s upon s raised to 3 by 2. Now putting this value of Laplace of ft here, so it is s into root of pi e raised to minus 1 upon 4s divided by, that is twice s raised to 3 by 2 and minus f0. Now see that here ft is sine root t, then also find here f0 is 0 because ft is sine root t and f0 becomes 0 because sine 0 is 0, so it becomes 0 and equal to 1 upon 2 Laplace of cos root t by root t. And 1 by 2 and this 1 by 2 will be cancelled. On simplification we get Laplace transform of cos root t upon root t, so it becomes root pi into e raised to minus 1 upon 4s upon s raised to 3 by 2 and it is minus 1, so we get s raised to half. That is our required solution of the problem, that is required Laplace transform of cos root t by root t. So this is the main application of Laplace transform of derivative formula. And now our next and last property, that is the seventh one, Laplace transform of the function ft under the integral sign from limit 0 to t. That is the special formula or property of Laplace transform. Now see here, if Laplace transform of ft is fs, then the Laplace transform of the function under the integration limit 0 to t, the limit 0 to t is fixed here, and ft. So the value of this Laplace transform under the integral sign 0 to t of ft is fs divided by s. I will explain this property by taking an example here. Now see that the problem is that find the Laplace transform integration 0 to t of sin t by t into dt. So we know that the Laplace transform of the function sin t by t is cot inverse s from our previous property division by t, right? And say it is fs. Okay, therefore by using the property Laplace transform under the integral sign 0 to t of sin t by t into dt, so it is fs by s. So dividing this cot inverse s by s, we get our required value of the Laplace transform under the integral sign. So these are the properties of Laplace transform.